Hello everyone, today we're going to be talking about number 238, product array of array except self. Let's take a look at the question. Given an integer array nums, return an array answer such that answer at element or at index I is equal to the product of all of the nums except for that number at that index. So let's just jump into the example right here. This is our input, 1, 2, 3, 4. How do we return this output where the first or the 0th index is the product of 2 times 3 times 4, and the first index is the product of 1 times 3 times 4, and so on. We're always finding the product of everything in the array except for the value at that index. So let's take a look at 3 at index 0, 1, 2. At index position 2, we want 1 times 2 times 4. And the constraint is it has to be done in linear time. So the first way to think about it is, okay, if I'm in position 1, I can run another loop that goes 2 times 3 times 4. If I'm in this position right here, where that element 2 is, I can run a loop that finds 3 and 4, and then have a loop that goes backwards as well. But that is a squared, O of n squared, because we're having 2 loops. How do we do it in one pass or in linear time? Let me show you the way to think about this problem. So up here, this is our example, right? And I have the solution down here, 12, 24, 12, 8, and 6. This is our solution. So when we're at this index right here, index 0, or the first element, that value is going to be 24, right? We're looking at 2 times 3 times 4, everything to the right of it. Now when we move to the first index or the second element, we are getting the value 12, and that is everything after 2, which is 3 times 4, and everything before 2, which is 1, right? And let's move on again. Let's look at it. Everything before 3, the product is 2 times 1, which is 2, and everything after 3 is just 4. And finally, when we're at the last element, everything after it, there's nothing after it, so that would just default as 1, the product, right? Because there's no change. Everything before 4, we have 3 times 2 times 1. So you can see that there is a split between everything before and everything after, which I'll call pre and post. So at 2, we need to find everything here and everything after. Here at 3, everything before and everything after, right? Everything before and everything after. How do we do this? Now, as I mentioned, there is a pre and there is a post, right? So let's look at it. At 2, we need the product of everything to the left, and we need the product of everything to the right. Similar concept. Now, to help you visualize this, right, I have the index on the first row here. I have our example input in the second row, and I have initialized two, you would say 2 lists or 2 arrays, pre and post. And finally, this is the result that we're going to be returning. So at I equals 0, is there anything pre? Is there anything before this value? There isn't actually, so this is just represented by a blank square, right? So if there's nothing, then we just say it's just 1. Our pre is 1. 1 times anything is going to be the same. Now if we move to the second element, or the first index here, is there anything before it? Well, it's 1. And 1 multiplied by the pre is just going to be 1. Okay, so 1 times 1, we need to always multiply the value by the pre. So if we move to 3, right, what's before 3? Well, the value 2 is before 3, and we want to multiply 2 by the most up-to-date value of the product, which is just 1, and that just returns 2. So what we're looking at is at index position 2, right? This pre-table gives me the calculation of the product of everything that comes before the index, right? So 1 times 2 is going to be 2. So everything before this value 3, the product is 2. And we move on. Everything before the value 4 the product is going to be 6, because we have the most recent value, which is 3, multiply that by 2, which is the most up-to-date pre, and we get the value 6. So we've done this pre-table, which basically tells us, okay, at index position 3, all the product of everything that comes before it is 6. At index position 2, everything that comes before it is going to be a product of 2, and so on. So we found the pre, now we actually have to find the post. Now we go backwards from the end of the list, right? Because there's nothing behind or post 4, we are going to just say, okay, post is going to be 1. And let's move to the left, right? Now it's going to be 4, because 4 multiplied by 1 is just going to be 4. So the product of everything that comes before 3 is simply 4. The product of everything that comes before 2, or comes after 2, is going to be 12. It's 3 times 4, or you can also look at it as 3 times our last post value, which is 4, and that gives us 12. And finally, when we're at index 0, what is the product of everything that comes after this value? 2 times 3 times 4, it gives us 24, right? Or we can look at it as the post value, which is 2, multiplied by 12, which was the most recent post product of everything, and that just gives us 24. And the result is just pre multiplied by post, right? So the idea, if we look at it, is this index, everything pre before it multiplied by everything after it post. So 1 times 24 is going to be 24, 12 times 1, 2 times 4, 6 times 1, 24, 12, 8, 6. So I'm not going to code the solution for this because this uses extra space capacity, right? We're creating 2 extra lists or arrays that's going to hold the pre and the post. The really cool solution is that we don't actually need these 2. So let me go through the thought process on that. So in this example, see, I've removed pre and post, right? We have our index still, and we have our input example, and we just have a result array. We're going to be using the result array to substitute the pre and the post. So just using the result array, right? Let's go through it again. So we need to find the pre, right? So at 1, because it's the first element, index 0, there's nothing before it, we can just say, okay, that pre value is going to be 1, right? Now we're here at index 1, right? And we look before it, okay, 1 multiplied by our last pre value is going to be 1. So we're just going to put in 1 in here. Now we move to the next element, index 2, okay? Now the value before 3 is 2. And 2 multiplied by the most recent pre-value is just going to be 2. So we put that here. And now we look at 4, right? The value before 4 is 3, the pre, and 3 multiplied by all the product before that, it's going to give us 6. So 1, 1, 2, 6. This is the pre-value of everything here, right? So at index 2, the pre-value is 2 because everything that comes before that value 3, 1 times 2 is 2. All right, so now we've done one pass. This is linear time. Now let's go post. We're going from the end again, from right to left. Okay, so is there anything after 4? There's nothing, so it should be just 1, right? So we're going to create a variable, instantiate that. So say let post is 1, and we're using let because we're going to be reassigning this value. So let post is 1 because there's nothing before it or after it. And we just say, okay, now let's move to, oh, well, there's one thing that we have to do. We have to actually multiply 6 times 1, which is just 6. So this doesn't change. So now we move 1 more to the left, right? Now this value is 3, but the value that comes after it is 4, okay? So 4 times the previous post value, which was 1, right? So before it was 1, so let post equals 1. We haven't updated that post value, so 4 times 1, right? 4 times 1 is just 1. 4 times 1 is 4. So you see how we're going to be multiplying 4 with this pre value because this is the post value. Post times pre, so 4 times 2, that's going to give us 8, okay? So now let's move to the left again. All right, now here we're looking at the value afterwards. That value is 3. 3 times the previous post value is going to be 4, and then we're gonna have to multiply that by this, which is 1, so that just gives us 12, right? So we've updated our post value, and we've multiplied it by our pre, which was 1, and now it becomes 12. And finally, we're at the first or the 0th index, right? And the value that comes before that is 2, and 2 multiplied by that previous post value, which is 12. So 2 times 12 is our post, and then we multiply that by 1, and that just gives us 24. And so let me jump into the code so you can see exactly how it's done. But the idea is the first pass, we find all the pre values, and the second pass, we start from the back and we find all the post values. So let's go right here. I have the code right here. So you can see that line 6, I've created my post variable. Line 7, I have the results, right? So this is the first loop right here where we go from left to right calculating the pre-values, and we're saving that in the results. So at index 0, right, if it's the 0th index, we're just going to push 1. So we can even just comment it right here. Right now it's going to look like that, right, with 1. And then as we go through, so we're going through this loop, right? At I equals 1, we're not in this branch anymore. We go into line 14. Okay, well, what was the last value that I saved in results, res? It's going to be 1, right? So 1 times I minus 1. We're at index 1 right now. So the example that we had, let's put it right here. It was 1, 2, 3, 4. I minus 1 is going to give us 0. So basically, it's going to be giving us index 0, which is 1. So you can see that, okay, it's 1, 1. We're going to push that in here. 1, 1. And now let's look at, okay, now we're at index 2, right? At index 2, we're looking at index 2, I minus 1. So we're looking at index 1. So that value is 2, right? So 2 times what was the last value? It's going to be 2. So it's 1, 1, 2. And let me check if that was correct. Yes, 1126. 112. Okay, now finally it's going to be 6. All right, so let's think. All right, index, we're at I equals 0, 1, 2, 3. We're at index 3, right, of this loop. Now I equals 3, so I minus 1 is 2. And let's look at our input value, 0, 1, 2. That value is 3. 3 times our most recent pre-value that we've calculated, up here it's 2. So 3 times 2 is 6. Now that gives us our pre calculations. And then this portion, line 19, it's going backwards, right? So we're setting I as nums.length minus 1, which just means that last index. And as long as I is greater than or equal to 0, we're going to keep decrementing I. And here, line 20, it's saying that, okay, if we're at the farthest right index, the last value, right? If it's the last value, we're just going to say, okay, it's what we're going to say is post, which is 1, right? Multiplied by res I, which is the index, but res I currently holds the pre section. It holds all of the product of the numbers that come before I, right? So, or that come before the value in 1, 2, 3, 4. So post times pre, we set our result. Now we've replaced that result with the last index. So now we're actually calculating, if we look to the left right here, we're calculating this value, 6. We're going to be updating it backwards now. Let's zoom in here. That's better. So as we move backwards, okay, once we're not at the farthest right, we move to the second last element. Now we're in this branch right here. All we need to do is say, okay, post, which is the calculation that we had before, multiplied by nums I plus 1. We're doing I plus 1 now instead of I minus 1, because now we're looking after that value. We're looking ahead. So I plus 1. And then we're updating that index value of the result every time with post times res the index value res the value that we access with this, because this is calculating all the pre-values, right? So I'm not going to iterate through this every time and time again, but this is the solution, and we can just hit submit. Oh, I can't really see it because it's outside of the recording. And yeah, it beats 35% of it. I hope this helps. That was a little bit convoluted, I think, but leave in the comments if you have any questions. Thanks so much.